Hello everybody, welcome to the 10th R Help video. Today I'll be going over what you need to know for homework 10. So let's jump right into it. The first thing I'll talk about is getting the standard error. So you're going to have S, whatever S is, divided by square root n. So you'll have to do this in your homework, and both of these things will be given to you. S, standard deviation, and n will be the sample size. And the reason why I mention this is because when you do p-norm, and you have your numbers, the last number, which you usually would just put in as your standard deviation, now you're going to put in this value, which calculates the standard error. Okay. So next thing, t-test. To do this, you're going to do t.test. You're going to do data, a column. You're going to set a mean equal to something. And then you'll need alternative equals, and there are several things you can put in. One of them is, and it gives you back t, degrees of freedom, your p-value, and your sample estimate. If you forget what alternatives you can put in, you can type question mark t-test, and then you can see it's two-sided, less or greater, depending on what you're looking for. Okay. Now that we've talked about t-test, and again, these will be given to you by the problem. The next thing we're going to go over is confidence intervals. We've done confidence intervals before, but the way you'll do it today is a bit different. So, as usual, get standard deviation, your sample mean, and just so you know, this and this are interchangeable. You can use both to create vectors. You have your n, your sample size value. Next, you have your confidence level, and all of these things are given in the question. So the first actual calculation will be for the standard error, which is SD divided by square root n. Now we have that. Now we can solve for the critical value, which is QT. 1 minus the conf dot level divided by 2, and then comma degrees of freedom equals n minus 1. Degrees of freedom are sample size minus 1 for this. You'll learn about degrees of freedom in more depth later. And then CI is the sample mean plus the critical value times your C negative standard error. And you just put it in this format every time, and it will give you your confidence interval if you run everything. And this will be your confidence interval for 90%, though you can change that. Next, removing rows. This is important because one of the questions will ask you to remove a row. So to do this, you do data. I'll write a generic version first. Data, row, column. And where you get row and column is looking at your data, and you can see the rows and you can see the columns. Let's say we really don't like row 10, and we really want to take it out. In that case, we would do data 10, comma, don't forget the comma, is equal to NA. Now we have wiped out row 10. Let's say we want the histogram for X, the X column. So, as usual, hist data X. Which you will also be asked to do, as usual. But let's say you want the standard deviation, as the homework will ask you. It doesn't show up. It says NA. So the way you mitigate this, or you resolve the issue, is writing a comma NA.rm equals true. Now it gives us the standard deviation. So if you ever have anything missing in your data set, do NA.rm equals true. So here, in short, here's it without that, and here's it when you do na.rm equals true. Next, we'll be going over one minus pt. So to do this, it will be on one of the last questions. You'll do 1 minus, the format is 1 minus pt, test statistic, comma, degrees of freedom. And to solve for the test statistic, it's x bar minus mean of null hypothesis divided by s divided by square root n. And as you might recognize, s divided by square root n is the standard error from up here. So you calculate this. Make sure you don't get your parentheses messed up. And x bar is the sample mean. And again, all of these things will be given to you. So let's say we have x bar of 21, mean of the null is 20, so 21 minus 20 divided by, let's say, standard deviation of the sample is 5 divided by square root, the sample size is 100. That gives you your test statistic, and then you want to do 1 minus test statistic, which is 1 minus pt, and then degrees of freedom, which is n minus 1, so 100 minus 1 is 99, and this would help you get your answer for that question. So I hope this is helpful. As always, email me with any questions you may have at holdenarcher1@gmail.com. Thank you for listening.